Dear student, in these lectures we have to study about the differentiation class 12 part 2nd, the most important chapters. In previous lectures we already complete the formula as well as some basic properties. First one, that is the product functions, next one, that is division of two functions, how to calculate the derivative. After that we solving the examples on composite function. But now in this lecture we are again solving the some more examples based on the composite function or chain rule. The question is very easy, so you can practice so many questions. If you not watch the previous videos, please go and watch that video so you can understood the formula. So before starting the chapter, we just revise the formula. Remember the some derivatives of x raised to n into x raised to n. Then a raised to x derivative a raised to x log of a, e raised to x derivative e raised to x, log x derivative that is 1 upon x, root x derivative 1 by 2 root x, constant derivative is 0. After that we have to remember the formulas of trigonometry. So remember that the sine derivative, that is cos, that is minus sine. After that tan derivative, that is sec square, and then sec square x derivative, that is sec x derivative, that is sec x into tan x. After that cot derivative, that is minus cosec square x, and then after that the cosec derivative, that is minus cosec x into cot of x. So then after that we go for the some trigonometric functions, inverse trigonometric functions. So remember the derivatives of inverse trigonometric function, that is the sine inverse x derivative 1 upon root of 1 minus x square, similar to the cos, only minus sign is there. Then tan inverse x derivative 1 upon 1 plus x square, similar formula for cot inverse, only minus sign is there. And then after that sec inverse x derivative, that is 1 upon x into under root of x square minus 1, similar formula for cosec, only minus sign is there. So in such way that we revise all the formulas of derivatives, and we start to practice to some questions basis on the composite function. So if you not subscribe to our channel, please go and subscribe, like, and most importantly comment if you have any doubts regarding the sessions. So let's start the question first. So now here we clearly observe that the y is the function of x, and now here there are the log bracket square first. Very simple question. So here the y is given and we have to calculate the dy by dx. So we solve the question by using the chain rule. So we differentiate first y with respect to x, we get, so dy by dx, so apply dy by dx on both sides, and then we get, so log of x bracket complete square. So what's our observation? Now this is the complete function raised to constant. So by using the first formula, the x raised to n equal to n into x minus x raised to n minus 1. According to that formula we solve. Now this is the complete x and this is the n. So according to this formula, so what is the answer of given example? So that is dy by dx equal to 2 into, according to this formula, x raised to n, that is n into x raised to n minus 1. So according to that, so what we get, that is 2 into, as it is log of, then log of x bracket complete, and now here power is 2 minus 1, that is 1, and then again take the derivative of that function. So we have to take the derivative of, that is log, then log of x bracket complete. So we know that what is the derivative of log? The log derivative is 1 upon x. So according to that formula, 2 into log of x, then the derivative of log, that is 1 upon x. So 1 upon, now this is term completely goes to denominator. So 1 upon log of x, and again we take the derivative of, that is log of x. And remember that next again, now what is the derivative of log of x? The derivative of log of x, that is again 1 upon x. So let's finish the example. So that is 2 into log x bracket complete. So on divided by, write down the term, that is log of into bracket log of x. And so tell me the formula. What is the derivative of log x, that is 1 upon x. So now this is the log having derivative 1 upon x, that is completely 1 upon log of x is there. So that is log of x, and again the derivative of log of x, and we know that what is the derivative of log of x? So derivative of log of x again 1 upon x. So write down the first term as it is. So then we get 2 times log of, then log. So question is very easy if you practice 1 times. So log x, write down before. So log of x, after that we write this term. So log into bracket complete, and then what is the rate of log of x? Again 1 upon x. So that is 1 upon x. Now this is the final solution of the given example. So the most importantly, remember the formula, how we utilize the formula. So on the basis of formula we calculate. Now this question we solve by using the chain rule, or we also call composite function. So very simple questions are there. To take the screenshot of the given example, or write down very fast. Make sure that a lot of practice make you perfect. So go through that practice. So we go for the next example. So we take some examples. Now next example is again very easy. So what is given? Y equal to root of tan x and then root of x, and we calculate dy by dx. Okay, very simple question. The first step you know that to taking differentiating y with respect to x. So we get, so first step is apply the d by dx on both sides. So then by using the standard formulas, so here we require the formula of root, and then we require the formula of tan of x. So what is the derivative of root x? So we know that the root x derivative is 1 upon 2 under root of x, and then what is the derivative of tan of x? So tan x derivative is, that is sec square x. So in such way that you just remember the basic formulas of given function, and then we solve it. So first when you observe that first is root, so taking the derivative of that 1 upon 2 into under root of, write down as it is, that is tan, and then under root of x. So then taking the derivative of that function. So which function we have to take the derivative? This is the complete function, we have to take the derivative. So then we take the derivative of that is tan. So tan under root of x. So then 1 upon 2 tan of root x. So what is the rate of tan? Now we already written here the rate of tan, that is sec square x. So remember sec square under root of x again, and then what is the function is there? So remaining function is, that is root x. So we can take the rate of root x. So complete the question. So final answer is, that is sec square x divided by, what is the rate of under root of x? 1 upon 2 root x. So that is, so we write down the derivative of root x 1 upon 2 root x. So we complete the final. So that is dy by dx equal to sec square x divided by, now here 2 into 2, that is 4, then root x into, so write down the remaining term, that is root tan of under root of x. So in such way that we calculate the given example. So now take the screenshot, or either writing the questions. Formulas are very easy. We only use the 2 formulas, and according to that we calculate the given example. Let's go for the next. So next question is again very easy. So here what is given? Now here the root is function is given, and after that e is given. So what is the derivative of root x? So we know that is 1 upon 2 under root of x, and then we require the derivative of x. So e raised to x derivative, that is e raised to x. So very simple question is there. So just differentiating y with respect to x, we get, so dy by dx equal to 1 upon, so first we apply the differentiating, after that taking the derivative. So that is e raised to power is given 3x plus 2, after that plus 5. So then, so take the derivative dy by dx equal to, what is the derivative of root? That is 1 upon 2 under root of, write down the function as it is, into the bracket 3x plus 2, bracket complete, and then plus 5. So again we take the derivative of. So what is the function? We take the derivative. So now this is the function, we have to take the derivative. So let's write down that function. So that is e raised to 3x plus 2 raised to power complete plus 5, and then take the derivative of that given example. So dy by dx equal to, so 1 upon 2 under root of e raised to 3x plus 2 as it is, and then plus 5. So what is the derivative of e raised to x? E raised to x as it is. So derivative is e raised to 3x plus 2. Again the derivative of 3x plus 2, take the derivative of function, now it is complete, and plus 5 is the constant number, so it is constant. And what is the derivative of constant? Derivative of constant is 0, remember that. So therefore the answer is 0. So what is remaining? And next, most importantly, whenever we take the derivative of 3x plus 2, so next step what we get, 3 as it is, then derivative of x, that is 1, and then derivative of 2, that is 0. Why? 2 is the constant function. So what is the remaining number? Only 3, remember that. So final answer dy by dx equal to, so very simple, 3 as it is, x derivative 1, 2, 0. So what is remaining? Only 3. So 3 into e raised to 3x plus 2 divided by, write down that number, 2 into under root of e raised to 3x plus 2 bracket complete plus 5. So now this is the answer of the given question. So very simple question. Make sure that write down or either take the screenshot of the given examples. So we go for the next example. So next example is again very easy. Y is given as the function of x, and then now x, there are two functions are there, one is quad, another one is log, and next is x cube. So tell me what is the derivative of quad x. So remember that derivative of quad x, that is minus cosec square x, and after that what is the derivative of log? So log derivative, that is 1 upon x, and what is the derivative of x cube according to the x raised to n formula. What is x raised to n? So x raised to n formula, that is n into x raised to n minus 1. So according to that formula, x cube derivative 3x square. So that is raised to power 3 minus 1, it becomes 2. So let's start. So differentiating the y with respect to x, we get, so then dy by dx equal to d by dx of quad cube into bracket log of x cube bracket complete. So what is the derivative of, and most importantly now here quad cube is there. So first we have to use the function raised to constant. Function raised to constant formula. Function is the quad and 3 is the constant. So according to, by using the first formula, that is n into x raised to n minus 1, after that taking the derivative of main function. So now 3 is the constant term. So first we solve. So 3 into quad square by using this formula, and write down the having angle as it is. So again we take the derivative of, what is the remaining function completely, that is quad into bracket log x cube bracket complete. So next 3 into quad square log of x cube bracket complete into, what is the derivative of quad of x? We already written the derivative of quad, that is minus cosec square x. So now here minus cosec square log of x cube bracket complete, and again what is the derivative of log? So that is d by dx of log of x cube. So then, so now your minus sign is there, minus 3 times quad square log x cube, and then cosec square, then log x cube bracket complete into, what is the derivative of log? So we already written here the log derivative is 1 upon x. So according to that, its derivative is 1 upon x cube. Again take the derivative of that function, that is x cube, and we know that what is the derivative of x cube? Now we already written that is 3x square. So final answer is, so that is minus 3 times quad square. Question is very easy. Make the practice, write down the examples. that is 1 upon x cube. And what is the derivative of 3x? So that is 3x square. So now you clearly observe that x square and x cube get cancelled. So single x is remaining at the denominator. So this is the final answer. And make the box. So your teacher can only observe that solution. So in such way that we solve a very simple question. So very basic observations are there. Once you look at that questions clearly and make sure that first in mind clear that which formula we can use, and remember that formula in your mind and go through one by one steps, so you can solve very easily. So derivative differentiation, it's only about the practice and practice. When you make sure that so many lot of practice, lot of questions solved by you, so then only it's possible, so you can achieve that goal. You can solving the so many questions basis on the differentiation. Once you understood the derivative differentiation, so next chapter is very easy, that is integration. Both are interconnected to each other, and then after that then we go for the solving the differential equations, applications of derivative on integration. So now the second part is completely based on the integration and derivative. Only 1 and 2 part is different. 1 and 2 chapters of the last are different. So so many questions are there for the practice. So make sure that go and watch the previous video, then you can understood what is the basic formulas of derivatives, and then go for the one by one properties. And now we complete up to the composite function. So let's we also solve some more questions. Okay, so take a screenshot of the given example or either written the example. Very easy. So we go for the next example. Next example is, so now here the y is given, that is e raised to sine and cos. There are the three functions are given. And now here sine cube is there and cos square is there. So definitely their function raised to constant. So first formula x raised to n, that is n into x raised to n minus 1. Second formula we use e raised to x derivative. So we write down the derivatives here. So that is e raised to x. Next formula, what is the derivative of sine of x? That is cos of x. And next formula, what is the derivative of cos x? That is minus sine of x. So these are the 4 formulas required. So make sure that all 4 formulas in your mind clearly remember. And after that we are going for the basic steps of derivative. So first we differentiating that y with respect to x. So be it. The question is very easy. So apply the dy by dx on both sides. So when we apply the dy by dx on both sides, and after that just observe the basic formulas, and then you can solve with an example. So what is the derivative of e raised to x? That is as it is. So e raised to 3 sine square x minus 2 cos square x. So then take the derivative of that function. So tell me what is the function here. Now this is completely function raised to power. So we can again take the derivative of that raised to power of e. So then 3 into sine square x minus 2 into cos square x. So make bracket after that. So e raised to 3 sine square x minus 2 as it is into. So tell me the derivative of sine. But before that, now here 2. Sine power is 2. Sine power is 2. Now it is the constant, and now here cos power is 2. It is the constant. So function raised to constant. Here also function raised to constant. So we can solving by using the x raised to n. So now here x is the sine, n is the 2. Here x is the cos, n is the 2. And after using that formula n into x raised to n minus 1, and then we go for the derivative of sine and cos respectively. So let's start. So question is very easy. So 3 into, so x raised to n, 2 into sine raised to 1 means sine x, and again we take the derivative of sine of x, that is sine is the function is there. So next minus sign as it is 2 into, so now here 2 into cos of x, and then what is the derivative of cos of x? We know that the write down that cos derivative and make the last answer of the given example. So let's we finish. So e raised to 3 sine square x minus 2 into cos square x as it is into into 3 2s are 6 sine of x into sine derivative that is cos of x minus 2 2s are 4 cos of x, and last one cos derivative is minus sin x, so that is minus sin of x bracket complete. So last step is, so e raised to 3, very easy question. So into 6 times sine. So now here we observe that sine cos, so we can taking the common sine and cos. So after taking the common sine cos, so what we get, so that is sine of x into cos of x. What is remaining inside the bracket? So now we have 6 minus plus, that is 4 bracket complete. So that is 6 plus 4, it becomes 10. So what we get now, so that is e raised to 3 sine square x minus 2 into cos square x into, so that is 10 times, so 6 plus 4, that is 10 times sine of x into cos of x. So now this is the final answer of the given example. So very easy. Take the screenshot of the given example, and most importantly you can solve the example in terms of sine 2 theta formula. If you remember the formula, sine of 2 theta equal to what? 2 sine theta into cos of theta. So we can write down the 10 sine as, that is 10 means that is 5 2s, so that is, and 2 times it becomes, that is sine of 2x, so it becomes 5 sine 2x. We can replace. Okay, we go for the next example. Is again very easy question. So here y is given and we have to calculate dy by dx. So just by, so before solving the question, so make sure that which formula we can use. Log is given, so we can solving the example using the log of x derivative, that is 1 upon x, according to that formula. After that sec of x is there, sec derivative, that is sec x into tan of x, and after that that is e raised to ex, that is e raised to e raised to x, and last one that is x square, that is 2x. So in such way that once you remember the formula in your mind, first log formula, then sec, then e raised to x, and then x square. So in such way that we solve the given example. So let's start differentiating y with respect to x. We get, so apply d by dx on both sides, so that is d by dx of log of sec x square bracket complete. So then take the derivative of log. So what is the derivative of log? 1 upon, so 1 upon sec of into the bracket e raised to x square, then again take the derivative of that function. Now what is the function is here? So that is completely sec is the function, so we take derivative of, that is d by dx of sec into bracket, write down as it is, bracket complete. So what is the derivative of sec of x? Sec x into tan x. So then we get sec x into tan x, so that is sec of e raised to x square into tan of e raised to x square, and then we take the derivative of the function. So which function is here? So function is, that is e raised to x square, so we taking the derivative of that e raised to x square. So e raised to x square, and then denominator is same. So we clearly observe that. So now the e raised to sec e raised to x square, and now denominator and numerator both are same, so we cancel each, and after that, so what is the remaining here? So only tan of e raised to x square into, what is the derivative of e raised to x? So e raised to x derivative, that is as it is, so e raised to x square as it is, but now here the function is x square, so again we take the derivative of x square, and what is the derivative of x square? That is 2x. So let's we complete the given example. So dy by dx equal to, what is the derivative of x square? That is 2 times x into e raised to x square into tan of, into the bracket e raised to x square. So this is the final solution of given example. So make sure that write down the given example, or either make the note, or either take the screenshot and solve the question at your home. Make a lot of practice. So let's we go for the next example. So next example is y is given and we have to calculate find dy by dx. So we have to solve the dy by dx. So very simple question is there. So we have to calculating dy by dx. So now in this question, first observation e is given e raised to. So what is the value of e raised to x? That is e raised to x as it is. Next is log. So log of x divided to 1 upon x. Again log, but now here x square. So x square divided to that is 2x, and next x raised to n, that is n into x raised to n minus 1. So according to this formula we calculate the given example. So let's we start. So now differentiating y with respect to x, we get, so apply d by dx on both sides. So once we apply the d by dx on both sides, e raised to log of into bracket the log x square minus log of x square. So take the derivative of given function. So what is the derivative of e raised to x? That is as it is. So e raised to log of into bracket log x bracket square minus log of x square. So now here what is the complete function? So function, now this is the complete function. We take the derivative of that function. So after taking the derivative of that function, that is d by dx of, so what is the function completely? Log into bracket log of x bracket square minus log of x square bracket complete. So what is the derivative of log of x? 1 upon x. So then e raised to log of, write down the term as it is. What is the derivative of log? That is 1 upon x. So this is the complete function of that log. So derivative of log, that is 1 upon x. So now complete terms goes to denominators. So write down log of x bracket square minus log x square, and then taking the derivative of that function. So that is log of x bracket square and minus log of x square. So what is the given answer? That is then e raised to, as it is, write down. Very simple question. You have to just clearly observe that. So make the practice, write down 1 times, 2 times. So you can remember the question very easily. Simple question is there. So what is the derivative of? Now here the function raised to constant. Log x is the function and 2 is the constant. So according to that function raised to constant x raised to n, we can solve the given example. So the answer of that given example, that is 2 into log of x, and again we take the derivative of log x. What is the derivative of log of x? That is 1 upon x. Next, now here minus, what is the derivative of log of x square? So log derivative 1 upon x. So 1 upon x square. Again we take the derivative of x square, that is 2x. So now we complete the given example, and from here 1x get cancelled and 2 by x is there, and again xx is the same for the denominator. So we can write the question so in such way that we get the final solution of the given example. In last step we have to only write down this term completely. So here 1x get cancelled, that is 2 into log of x minus 1 divided by x. Now this is the term because the x is the like fraction is there. So we write down the single times at the denominator and taking the addition subtraction of the numerator by using the what is the sign convention is between them. So let's take the screenshot, taking the writing the question. Very easy question. Many times such questions are asked into the examinations. So whenever you make a lot of practice, then you can solve very easily in minimum times, in less time. Then only you can achieve that your goal. The question will be finished within time. Next question again is very easy. So now here we have to calculate dy by dx of the given example. So again differentiating y with respect to x. So we get, before that we just observe that your sign is given. What is the derivative of sine? Sine derivative is, that is cos, and what is the derivative of cos derivative, that is minus sine x. Now here function raised to constant is present, so x raised to n equal to, what is the derivative of x raised to n? So x raised to n derivative, that is n into x raised to n minus 1. So and after that again x square is given there, so x square derivative, that is 2x. So once you create in the mind, remember the formula, which formula we can use, when you solve, it's very easy to calculate. So that is applied dy by dx on both sides. So that is d by dx of sine square x square minus cos square x square bracket complete. So let's restart. So what is the derivative of function raised to constant? Function is the sine x and 2 is the constant. So what is the derivative? 2 into sine x square, and again take the derivative of sine x square. Next, minus, what is the function raised to constant? 2 into cos of x square into, again taking the derivative of that function, that is cos of x square. So then complete the example. 2 into sine x square into, what is the derivative of sine x? Cos of x square, and again take the derivative of that function, it becomes x square, minus 2 into cos x square into derivative of cos, that is minus sine x square, and again take the derivative of, that is x square, and what is the derivative of x square? We know that 2 times x, so that is, it becomes, so 2 into sine of x square into cos x square into, that is 2x, derivative of x square, minus 2 into cos x square into minus sine x square into, that is 2x. Final answer we can take in the common sum terms. So which terms are now here common? First is the 2, then second is 2x, 2 and then 2x. So total term we take in the common, that is 2 2s are, now here 2 2s are 4x. So 4x we take in the common. Very easy question. Also now here sine x square and sine x square, again similar, most importantly cos x square again simple, and if now it is 4 times and it is also 2 2s are 4 times, and minus minus, that is plus. So very simple question. I again repeat, 2 complete term is similar, minus minus becomes plus, and then addition of 2 2s are now here 4, and now here multiplication of 2 2s are, that is 4, 4 plus 4, that is 8. So what is the final answer of the given example? 8 times sine x square into cos x square. Now this is the final answer of the given example. So make the note in such way that we calculate so many examples. Let's go for the next. And the next example is very easy and important. Many times they ask into the examinations. So clearly observation. Now their log is given. What is the derivative of log x? So remember the basic formula of log of x, derivative 1 upon x. Then derivative of sec of x. So that is sec of x, derivative, that is sec of x into tan of x, and then what is the derivative of tan? So tan derivative is sec square x. So in such way that we are solving the question. So applying the differentiating y with respect to x we get. So apply d by dx on both sides. So we get. So after applying d by dx and by using the basic formulas of the derivatives, so then we can solve the given example. So what is the derivative of log? That is 1 upon x. So write down the function completely at the denominator. Sec 3x plus tan of 3 times x. Again we take the derivative of sec of 3x plus tan of 3x and make the brackets. And then write down the derivative. So what is the derivative of sec? That is sec of, so now here we already written sec derivative sec x into tan x. So sec of 3x into tan of 3x, and again plus. So now here what is the derivative of sec of 3x? So again we take the derivative of 3x. So whenever we take the derivative of 3x, remember that x is the function having derivative is 1 and 3 is the constant. Now it is as it is, plus tan derivative, that is sec square 3x, again taking the derivative of that function, and the function is, that is 3x. On denominator is as it is, sec of 3x plus tan of 3x. So we clearly observe that from the numerator. So what is the derivative of 3 times x? Derivative is only 3, x derivative is 1, that is 3. Now 3 is as it is, and the x function having x according to the x raised to n, having as n into x raised to n minus 1, 1 into x raised to 1 minus 1, 1 into x raised to 0, anything raised to 0, that is 1, so that is only 1. So that is 1, 3 times 1. So now here what term is common? So now here term is common, that is 3. Here sec of 3x, we can take the one sec of 3x common. So after taking the common, so what we get the answer? So let's rewrite. So after taking the common 3 into sec of 3x, what is remaining into the bracket? 3 into sec of 3x, so remaining only tan 3x. And from here 3x and 1 sec of get cancelled, 1 sec of 3x remaining, denominator is, that is sec of 3x plus tan of 3x. So next we clearly observe that numerator denominator is same, so we get cancelled, and the final answer of the given example, dy by dx equal to 3 times sec of 3x. Now this is the final solution of the given example. Now it is the IMP question. Many times they ask into the state board examination like the simple questions. So make the practice lot of, remember the formulas so you can solve easily. Let's go for the next example. Make the screenshot of all questions so you can calculate or solve at your home. Next question, we have to solve the derivative of the given function, and we have to calculate the dy by dx. So again, before solving, just observe that the question and which functions are given. First function is cos. We know that what is the rate of cos of x? Remember fast very, minus sine of x. Next is, that is log. So what is the rate of log of x? That is 1 upon x. Next x square plus 7. X square is that is x square into that is 2x. And most importantly, function raised to constant, that is x raised to n. So n into x raised to n minus 1. But using all the formulas in your mind clearly, then we solve it. So differentiating y with respect to x, so we get apply the d by dx on both sides. So once we apply the d by dx on both sides and then taking the derivative of that given function, so then we solving the example. So what is the derivative of cos? Before solving the derivative of cos, remember that here cos is the function and 2 is the constant. So by using the x raised to n formula, so we first apply the x raised to n formula, then we solve the example. So that is 2 into cos of 2 minus 1 as it is, and then log of x square plus 7 bracket complete, and then take the derivative of, so we take the derivative of cos of log of x square plus 7. So tell me what is the derivative of cos of x? That is minus sin x. So according to that formula, so we can solve the derivative of the given function. So tell me what is the derivative of cos? That is minus sin of, write down the bracket as it is, log x square plus 7 bracket complete, and then derivative of log of x square plus 7, and what is the derivative of log of x? That is 1 upon x. So according to that formula we solve, minus sign is there, so minus 2 times cos of log, so we write down the example, and then sin of into the bracket, we complete the given question, and last, what is the derivative of log of x? 1 upon x. So according to that function is x square 7, so 1 upon x square plus 7 into d by dx of x square plus 7. So tell me what is the derivative of x square? X square derivative is 2x and 7 derivative is 0. So remember, this is the derivative of the given function. So last we finished the given example. So that is, so minus 2 into so very simple question. Now we have 2x. So now this is these 2x and this 2, it becomes minus 4x. So here we write down minus 4 times x. So we take that number at d4 minus 4 times x and denominator as it is, that is x square plus 7, and now this is the term dy by dx. So make the bracket. So take the screenshot of the given example. So in such way that we solving the so many questions basis on the composite function or chain rule. So make sure that make the lot of practice, go through all lecture series of differentiation. We complete formulas as well as some properties, division, multiplication, composite rule, or chain rule. So if you have any doubt, you can text me. Most importantly, if you have not subscribed the channel, so please go and subscribe the channel. Most importantly, like it and comment on that. You can share that channel with your friends so they can also study, because your state board examination is very near. So only 2 months are there. After that you have to going for written examinations of class 12, and then you go for the CET. So make sure that you watch all videos, make practice a lot of, and you should get the very good marks. Thank you very much for watching our videos.